Welcome to our lecture. Okay, so now this is our last time we are discussing about the energy conservation in motive power. So we found that there are number of motors are there, uh, but three-phase induction motor occupy nearly 90% in the motive power. So we will discuss only especially for the three-phase induction motor and three-phase induction motor it is the squirrel cage induction motor. So we discussed about the pointer for the user when someone is going to purchase large number of small motors, because in case of a small motor the efficiency is smaller. So we have to take care about the no load current, no load losses, no load power factor. Similarly, the efficiency and power factor at 75% and 80%. Now if you use the energy efficient motor, definitely uh, the energy efficient motor is going to work at improved power factor, as well as at 50% loading it will give the appreciable efficiency, whereas for the standard motor the efficiency will be smaller at small percentage of load. So this is the one standard motor as well as the higher efficiency motor. It is the standard motor, suppose it is the 5 HP motor, the efficiency is only 80%, whereas the 5 HP motor of energy efficient type, it is 88% or 90% is there. So if there are large number of motors are there where it is in the capacity of 10 HP or 15 HP, it is advisable to purchase the energy efficient motor, because the quantity is more and the energy of standard motor, efficiency of standard motor for smaller capacity is very small. See here, if it is a 2 HP motor, the efficiency is only 78%, okay, whereas the efficiency of energy efficient motor is 85%. So if you are having in the industry, if you are having number of motors 2 HP or 5 HP motors large in quantity, definitely the working efficiency of the system and the power factor will be very poor, and hence it should be replaced by the energy efficient motor. So last time we have seen the energy efficient motor. Now how to find out the loading of motor? The motor loading can be calculated by measuring the input power and nameplate reading. Every motor have some nameplate reading. That nameplate reading is nothing but the rated output of the motor. So where it is written as a HP or kilowatt, it is the rated output of the motor under full load condition, current under the full load condition. So now rating is the continuous maximum rating or continuous rating, that is a type of duty is there. It is written on the nameplate. So with the help of measuring input power, we are able to calculate the percentage loading. So percentage loading on the motor is equal to the input power drawn by motor divided by nameplate full load kilowatt output. So suppose it is a 10 HP motor, 10 kilowatt motor, and it is taking 4.8 kilowatt divided by 10. So the meaning is that it is a 48% loading is there. If suppose it is consuming or it is drawing 77 kilowatt divided by 100 kilo and 7 kilowatt divided by 10 kilowatt, it means that it is a 70% loading. So the motor loading will decide either it is going to run and the good efficiency condition and power factor. If the motor loading is small, less than 50% or 60%, definitely the working power factor of motor will be poor, as well as the efficiency of the motor will be poor. So in this contest, we have to calculate the if loading of the motor. Each and every motor should be tested. Now, how to calculate the input power? It can be measured with the help of, without disconnecting, with the help of some tongue tester and multi-function meters are there available in the market. So we are able to calculate the power factor kVA, kVAR, as well as the kilowatt input of the motor without disconnecting only from the its control panel. We are able to calculate. We are able to measure the power. or simply we can calculate the percentage loading from the current drawn by the motor. The current drawn by the motor, input current drawn by the motor, which is easily measured with the help of tongue tester or say CTPT units, CT units are there. So we are able to measure the current, and nameplate full load current. So divided by nameplate full load current, so it is give the full load, it will give the percentage loading of the motor. So the percentage of the loading motor can be calculated by measuring the power input divided by full load kilowatt rating, and measuring the current input of the motor divided by the full load current of the motor. So by this way, by these two parameter, we are able to measure the percentage loading. Once the percentage loading we have calculated, we have observed, now we can do the action. If the percentage loading is 50% or less than 50%, we can connect the motor in star instead of the delta. In the delta, what happens? The rated voltage is going to apply it across the phase to phase, or in the per phase voltage, and phase voltage is same in case of the delta connected motor. Now, if you are going to change into the star, so what will happen? The phase voltage is going to reduce, therefore the iron losses is going to reduce, because the iron losses depend upon the rated voltage. So suppose for example the rated voltage is 415 volt. So the somewhere there is a some uh, say iron losses are there. Now if the voltage is reduced by 230 volt, so iron losses get decreases, but that decrease in voltage reduces the starting torque. So where the starting torque does not matters, in many of the applications we can change permanently from delta to star, which will decrease the iron losses, hence it will improve the efficiency. So earlier the motor is working at 50% loading, the efficiency say 70%. By changing delta into the star, the motor if working efficiency at the same percentage of load, it is going to increase by 70 to 80% over there. So it has been observed. So this is the very good recommendation. It does not need any investment for all small motors which is lightly loaded, that is loading below the 50%. It can be the connection of delta is going to change in the star one. So from delta to star connection, the loading of the motor can be increased, or we can say that the working efficiency of the working efficiency of the three phase induction motor can be increases. So without any investment, we can do this. Second is the underloading. So we can calculate underloading and oversizing. Many of the motors are oversized, where the it is not necessary to install the 10 HP motor, only 7.5 HP is okay, or it may be 5 HP is okay. So there is a oversized motor in many of the say industries. It is found that, suppose I will give the example, suppose this is the water tank is there, okay, and second one more water tank or some fluids are there. We want to pump the fluid at some particular discharge level. So it is done with the help of some motors. Say this motor, centrifugal motor is mounted over here, and by this way it is say 20 HP motors are there, or 20 HP pump is there. Now it is found that the discharge of fluid is very high. So I want to control this discharge level. So many of the in industries, it is found that they are using some sort of diverters over there. They are using a small outlet, and again it is put into the same underground tank. So whatever the pump is water is pumping with this motor, 20 HP pump is there. So now the flow rate is very high. So by opening the wall from this one diverter pump, pipe diverters are there. Some of the water is again put into the same tank, and we are able to control the output or discharge level. So, but this diverter is nothing but the losses in the system. It means that whatever the pump is installed, it is the oversize. It is not needed to use the 20 HP motors 20 HP pumps, only 15 HP or 12.5 HP is sufficient. But because of the oversizing of the motor, oversizing of the pump, we are controlling the discharge with the help of some diverters are there. So this is the wrong practices are found in many industry when energy audit is going to conduct it in the some particular factories are there. So there this is the normal practice because of the oversizing motor. So if there is a oversize, what happen? The motor does not load it properly. Once the motor loading is small, this percentage loading is set 50% or less than 50%, 40% are there. Definitely the efficiency very small. Since the efficiency curve, it is the percentage load and it is the efficiency, it is found that the efficiency is very small at a small percentage, and up to the say 80%, here say it is 80%, it will give the proper efficiency at a higher maximum efficiency, whereas at 50% the efficiency is very small. So this is at 50%, the efficiency is very small. So to improve the percentage loading, either the motor may be connected into the star, or whatever the oversizing of the motor can be replaced by the proper one. Second effect of the losses in the motive power is the rewinding of the motor. It is found that each after rewinding of the motor, the workmanship will not be same as it was new. The air gap between the rotor and stator get increases. Because of this increase in air gap between the stator and rotor, definitely the motor will draw more reactive current and work on the poor power factor. Means the magnetizing current, the no load current get increases, and because of this no load current, magnetizing losses, that is the iron losses, as well as the say it will draw more current, reactive current, and hence the motor is going to work at poor power factor. So because of this rewinding, it is better to replace it by the new one. Once the motor is rewound by 2 or 3 times, so it is recommended that instead of repairing more and more time, it is better to replace it by the energy efficient motors. In many times we found that we are going to carry out number of time winding in the agriculture pump. So this type of work is this type of difficulties are in the agriculture sector. The people are not purchasing the energy efficient motor. Farmer are not ready to purchase the energy efficient motor. The one reason is that the cost of the machine is very high. Second, they are not the farmer are not getting the proper voltage and power quality. So power quality is a very big issue. If somebody is not getting the proper voltage level, constant voltage and constant voltage, definitely even by purchasing the energy efficient equipment, it does not perform well. So it is quite necessary that the power quality should be proper. So this is the one parameters which affect over the losses of the system. Okay, so now this is the now next parameter is speed of the induction motor. Based on the speed of the induction motor, we can mount some capacitor, that is we can connect some capacitor to improve the working if working power factor of individual motor. Power factor improvement can be done with the help of central level, with the help of APFC, automatic power factor controller. It is mounted in the substation and it is going to control entire power factor of the factory or entire power factor of any premises. But it is found that in many of the motors, higher capacity motors, when it is going to work at lower power factor or because of the maybe loading, we can it is recommended to connect the capacitor near terminal of the three phase induction motor. So one advantage is that the power working power factor of the motor get improved. One thing. Second, whatever the reactive power needed to the motor, earlier it is drawing from the supply main, it has been reduces, and locally we can produce the uh, say we can produce uh, the say what are, we can say that reactive power locally. Okay, so I just try to show this the same things with the help of diagram. For example, this is a motor is there and it is connected with the source supply. Now here this is the motor. Okay, it is the load. Now, what are the points? What are the power are going to supply? It is the kVA. It is going to consume by the motor kVA, which is the combination of active power, that is the kilowatt, active power kilowatt, plus J reactive power, kVAR, kVAR reactive power. Okay. So whatever the reactive power we are taking from the source, it is the source, supply source are there. So when the motor is taking the reactive power from the source, it will draw active power, which is used to convert into the motive or useful power, whereas this is the reactive power. So the total current in the distribution line, it may be a cable or some things are there, whatever the overhead conductors, or it may be some cables are there, it become overloaded or the current will be high. Now, if you use some capacitor near to the terminal, if we are using one capacitor to the near to the terminal of a three phase induction motor, what happen, whatever the leading lagging kVAR needed by the motor, it is going to supply by the capacitor. So it will supply the leading kVAR. Capacitor will supply leading kVAR, and hence we can say that we are partially eliminate or totally eliminate the kVAR from the source. When we are reducing the kVAR from the source, the value of kVA get decreases, and hence the current in the conductor also get decreases, which will reduce the copper losses in the transmission conductor or cables are there, one thing. Second, it will improve the voltage, whatever the voltage is going to drop in the length of the wire, length of the cable, it also get eliminated. And the reactive kVAR is fulfilled by the local capacitor connected near to the motor. So what would be the capacity of motor, capacity of capacitor to be connected? It is depend upon the motor size as well as the speed of the motor. So now we will see what is that. So I think it is quite clear from this diagram what is the advantage is there. Okay. So now we have a, this is the capacitor rating for the power factor correction by direct connection to the induction motor. Whatever the induction motors we are using, we can directly connect. So here it is the motor rating in HP, 5 HP, 7.5 HP up to the 100 HPs are there. No doubt there we can calculate very well with the help of some formulas. And this is the capacitor rating, the capacitor rating in the kVAR. So here the motor speed is there, 3000 rpm, 1500 rpm, 1000 rpm, 750, 600 and 500 rpm motors are there. So suppose for example it is a 10 HP motor is there. At the 10 HP motors, if the motor speed is 3000, it is recommended to connect the 3 kVAR capacitor. If it is a 1500, again it is a 3, but at 750 rpm and 500 rpm the capacitor rating get increases by 4, 5, 6. Okay. So the meaning is that if the speed of the motor is high smaller, the rating of the capacitor get slightly increases. So just it is a thumb rule, it is the one third of the capacity of motor. Say for example it is a 100 HP, the here the size it get decreases 20 kVAR, whereas in the 1500 rpm, because most of the motors are 1500 rpm, it is a 22 kVAR. So by connecting this value of capacitor, uh, uh, it is here by connecting this capacitor we are able to improve the working power factor of the motor. Now this can be calculated with the help of formulas. The formula is, I will write over here itself. So power capacitor or capacity of the capacitor kVAR is equal to active power consumed by the load, whatever the active power. If it is a 10 HP motor, so 7.5 kilowatt is the capacity of the motor, into bracket uh, tan theta 1, tan theta 1 minus tan theta 2, tan theta 2. So by this formula, we can calculate the power capacitor to be connected to the induction motor. Even it is also, this formula is also applicable for improving the power factor. For example, the initial power factor is zero point 0.8 and I want to improve the power factor by unity. So zero point 0.8 means the angle is 36.86. So tan 36.86. Theta 1 is the initial power factor angle before, that is the before improvement of the power factor. And theta 2 is the new power factor angle. So new power factor angle will be 0. So tan theta 0 is there. Tan theta 1 is the 36.86, 8.8 power factor lagging, multiply by the capacity of motor, or it may be the capacity of plant is there. So we can connect with the help of capacitor, the capacity of the capacitor. For example, in any premises, or say for the college example, the load is 100 kilowatt, okay, and I want to improve the power factor from zero point 0.8 to 1. So I will calculate theta 1, which is the cos inverse of zero point 0.8, that is the tan theta 1. We will write tan theta 1 minus tan theta 2, where theta 2 is nothing but the 0 for the power factor improvement at unity power factor. And this way we will calculate the kVA of the capacitor. Now this kV of the capacitor is used for the APFC, so we will make some steps. Say for example 100 kVR is the capacitor needed, so we will put 20 kVR, 20 kVR, then it is a 40, then 10, 10, 10, so it become a 70 kVR, then 5, 5. So by mixing the number of steps, so that we are able to maintain the power factor with the help of small changes. So fine adjustment can be done with the help of proper selection of the step in the capacitor. So this is the formula for improving the power factor of induction motor. This is based on the speed of the motor as well as the capacity of motor, and it can be calculated with this formula also. So this is the case where we can improve the power factor. Now, second, a very effective tool or effective method in the motive power to reduce the power consumption is the variable frequency drive. So, what is the variable frequency drive? We found that the speed of the motor cannot be changed. If you want to change the speed, we have to use some different ratio of gears. It may be a belt drive, it may be a chain drive, or it may be a direct coupling through different gear ratios are there. And because of these application of this V belt, flat belt, so there is a always friction, and hence the friction losses get increases. The motor, if the motor speed, most of the popular motor speed is a 1500 rpm, that is the synchronous speed. Motor is going to run at 1440 or 1460 rpm. But if you want 1300 rpm, we have to use the gears, or if you want some 1600 rpm, again we have to use the gears. So this is the use of the gears, maybe a flat belt, maybe a V belt, it gives the losses, one thing. Second thing is that three phase, many times we are using the DC motor. The DC application of DC motor is because of the high starting torque, and second is the easily we can change the speed. So speed variation, change in speed is quite possible and simple in case of the DC shunt motor, DC series motor. So therefore we are using the DC motors. But what are the drawback of the DC motor? One thing is that we have to use the converter, it will make the system unbalanced. There is a continuous friction between the commutator segment and the brushes, so we have to give the attention toward the maintenance. Now there is a sparking over the brushes, so we cannot use that DC motor where ethane, methane gases are there, or petroleum or some chemical industries are there, because it lead to the fire in the premises. So these are the limitation of the DC motor, but it has an advantage of high starting torque and variable frequency. Now this variable frequency, variable speed and starting torque deficiency of three-phase induction motor can be overcome with the help of variable frequency drive. In case of variable frequency drive, we are able to change the supply voltage level as well as the frequency. So by changing the frequency, we are able to change the speed, and similarly by changing the voltage level, we can use the high starting torque. By maintaining the ratio of frequency and voltage, we are able to maintain the high starting torque. So we found that nowadays three-phase induction motor are using in the railway traction, whereas the requirement of ideal requirement of railway traction is high starting torque. And three-phase induction motor does not give the high starting torque, but the application of variable frequency drive with the application of thyristor family converters are there. Now three-phase induction motor become compatible for railway traction also. First thing is that. Second thing is that by changing the speed and by reducing the supply voltage, now it become to achieve the energy conservation in three-phase induction motor. So nowadays, I think you are much more familiar about the inverter AC. Inverter AC means it is not going to work on the inverter, whereas it is fitted with some variable frequency drive. Once the temperature is reaches, the speed of the blowers or speed of the compressor is going to reduce by with the help of variable frequency drive. That is the electronic component, thyristor family components are there, and hence we can decrease the power consumption, where the in case of conventional compressor and conventional ACs are there, the speed will remain constant even though the temperature is reaches. So the remarkable energy conservations are found with the help of variable frequency drive. So nowadays AC drives are more popular in the industries. So the second method, the next method is the the method is the use of variable frequency drive in case of induction motor, and hence we can achieve the energy conservation. So what are the different type of loads are there? The loads flow is proportional to speed. If you want to increase the flow or if you want to maintain the flow, we have to keep the speed constant. Head is proportional to square of speed. If the head, that is the lifting height of the fluid or water is there, it is depend upon the square of speed. Torque is proportional to square of speed. So where the you require the high starting torque, speed is more. Power is proportional to q by speed. So this is the some relation are there for the different type of loads are there. Okay. So now this is the data collection. If you are going to collect the data for any type of motor, what we'll do, say there is a some soap industries are there, so fatty acid plant are there, handling water, raw material handling is there, effluent treatment plant is there, some chemical process plant is there, production area is there. So write down the name of area, compressors, utility section, okay, then cooling towers. So write down the name, rating of the motor, whatever the motors are there, 10 HP, 20 HP motor, rated current, what is the rated current, what is the full load current, or how much current it is taking, kilowatt, how much power factor. And so by developing this chart, now once we are able to calculate the loading, percentage loading, we can take the action over the that particular motor. For example, I will put here, it is a cooling tower is there, okay. Now here the rating of the motor is 20 HP. The rated current is 30 ampere, whereas the motor is drawing only 15 ampere. It is mean that the percentage loading is smaller. Once the percentage loading is smaller, what would be the kilowatt, what would be the kVA, what would be the power factors are there. Now we will put one more action plan. What type of action to be taken out? We will give the action is that we have to change connection from delta to star. This is the connection. Or we will write it is the oversized motor. So we will replace it by the proper side. Now it should be replaced by the energy efficient motor. So we will write. So by taking the proper data for the different type of motor, different location, and we are able to take the decision based on the data collection. Okay. So from the next time we will take the energy conservation in lighting section. Thank you.